Okay, let's take a look at problem 752. How can I make wholes? Janice, the club's president, began to think about how she could visualize 4/7 x to help her solve her equation from problem 751. So remember, our equation from problem 751 was 4/7 x equals 9. So in her mind, she is visualizing this diagram to the right. Part A wants to know, does this equation map represent your equation from problem 751? Why or why not? Well, if you look on the left side, what they are showing you is this entire piece here is representing one X tile. However, notice how it is broken into 1, 2, 3, 4, 5, 6, 7 pieces. So the one X tile is broken into sevens, and notice how 4 of those sevens are shaded. So we could say on the left side that we have 4/7 x, and on the right side, let's count them, we have unit tiles or one tiles. So that's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it does look like we have 4/7 x equals 9, but we need to explain why or why not. So I'm going to go down here, and I will say for A, yes, it represents Janice's equation. The left side shows 4/7 of an unknown, or x, and the right side shows 9. All right, on to part B. Janice recognized that these numbers were not easy to work with since she did not have whole tiles. After working on her paper for a while, she said, maybe I can make whole tiles using more than one set of partial tiles. She drew the diagram at right. What is her new equation as represented in this picture? Okay, I am going to erase what we have for A now so I can make room for B. So if you notice on the left side of this equation, it looks like Janice, we started out with one just one X tile that was sectioned into 7 pieces or partitioned into 7 pieces, and now we have 1, 2, 3, 4, 5, 6, 7 of those. So it looks like she multiplied by 7 on the left. Now let's see if she did that on the right as well. We have one group of 9s, 2, 3, 4, 5, 6, 7. So it looks like what she did was multiply by 7 on each side. So what we need to do is write her new equation that she has represented in this diagram. So it looks like she has 7 groups of that 4/7 x on the left side, and then on the right side it looks like she has 7 groups of 9. So if I multiply 7 by 4/7 x, I would get 28/7 x. And if I multiply just my 7 and 9 on the right side, I would get 63. Oops. There we go, 63. Now 28/7, if you remember, that fraction bar means the same as divide. So we can actually make that into wholes. So 28 divided by 7 would give us a nice even 4. So 4x equals 63. Now let's divide by 4 on each side. 4 by 4, if you remember anything divided by itself, gives me a 1, a giant 1, which leaves me with 1x, or just x, and 63 divided by 4 is going to give me 15 and 75 hundredths, or 15.75. Interesting. It looks like that matches my answer from part A. Well, let's have a look at question C now. So it says, with your team or class, discuss Janice's strategy for solving this equation. During your discussion, answer the following questions in any order. All right, I'm going to go ahead and get rid of part B to make room for C. All right, so I'm just going to look at the questions from the top to the bottom. So what made Janice's strategy different than what you did in lesson 714? So what I would say is, in Janice's strategy, she was trying to make an integer coefficient of x. Now remember, the coefficient is the number that comes before x. So basically what it means when I say she was trying to make an integer coefficient was she was trying to make a coefficient that was not a fraction and not a decimal. All right, let's take a look at the next question. How many sets of 4/7 x did Janice use to get a whole number of algebra tiles? Well, we kind of looked at that a little bit in part A and B. So she used 7 sets of 4/7 x. That is how we got that 28/7 x. All right, on to the third question. Why did the right-hand side of the equation change? So she had 7 sets of 4/7, or we could say she multiplied the left side by 7. So she did the same thing to the right side. And the reason she did that is because we need to keep the equation balanced. So, this shows us that, whatever we do on one side of the equals sign, we need to do on the other side. That is keeping that equation balanced. And finally, last question, how does the number of sets Janice used relate to the equation you wrote in part A? Well, our equation for part A showed 7 sets of 7/4 x. So we could say we multiplied the 7/4 x by 7. All right, and that is all for question 752.